what are these hardening guidelines? Because hardening is a very, very different phenomenon. Where does this hardening come into picture? So as you could see on the right hand side stress strain curve, beyond that particular, when it's beyond this elastic limit, your plastic plateau starts developing, which means like a permanent deformation starts developing. And beyond the permanent deformation, when the strain starts increasing, although with the development of stress, and the strengthening happens. So this is where hardening comes into picture. So it becomes more hard. Even if you unload it, the permanent deformation is not going to it's not going to come down. It is just going to stay there. So it becomes more strengthened. Now this is known as strain hardening, because it's based, no matter the stress increases, the strain also increases in addition to the stress, and it strengthens beyond a particular material with more permanent deformation. It is definitely not going to come back to its original position. So as a result of plastic deformation, when it happens, now the whole hardening comes into picture. Why we examine this hardening is because, as I told you, everything, the crack happens at the surface. So before the crack happens at the surface and takes a deep cut inside the material, this is how it behaves with the stress strain curve. So in the process of understanding the stress strain curve or the plastic deformation, we are going to examine how the yield surface changes with respect to the yield surface that initially that you have beyond the elastic limit, how it is going to change with respect to the size and the center, probably the orientation and the shape of that particular material. Based on this, the hardening guidelines have been derived. So when there is isotropic hardening, which means there is a uniform expansion of the yield surface all over the direction, be it sigma 1 being x, sigma 2, sigma 3, your yield surface that is going to expand is going to be uniform in all the three directions, like as in circular in nature that you see over here. So when you see it plotted, the behavior on a 2D, on the other section, this is how it looks like. So, okay, are we confused with the isotropic term that we use in the material? Definitely, it is different from the isotropic material yield criteria that we are talking about. That is a material orientation. Here we are mentioning isotropic for the kind of expansion of the yield surface that happens during the plastic flow. And the other major hardening guideline that one must observe when they model the nonlinearity is kinematic hardening. So here, the yield surface translates from its original position, in the sense like everything starts from the original position. So, but the yield surface is not going to, you will have an initial yield surface, and then subsequently your yield surface, after uniform expansion, you will have the subsequent yield surface like this. But kinematic hardening is from the original position itself, the yield surface starts translating. So there are certain, these are the guidelines which needs to be kept in mind when to use isotropic, when to use kinematic. When you take a deep dive into the material modeling, you will get to know and you would gain the knowledge and the experience when you work with it. So coming back to the material models that I said, current commercially available state-of-the-art FEA tools had developed various material models to capture the differences, because every material is going to behave differently when you subject it to the test conditions, and it is going to make difference in the material properties as well. So how do we simulate whatever that happens in reality with the material when it experiences a deformation? So what FEA software providers did was they developed the codes or the mathematical models to characterize the materials that happens on the field, to ensure that a kind of a mathematical modeling, which is the material model, do a curve fitting and try to have such kind of characterization when we simulate the nonlinear conditions. So here's a quick summary of various material models. You don't have to worry about the terminologies over here. You will definitely come across this when you start characterizing your material. When you're dealing with elastoplastic, the material model that you need to choose is von Mises or Drager-Prager. And for what materials this works well, definitely any plastic plateau that has been shown before reaching the tensile strength. And most engineering metals and some plastics you model using elastoplastic. And the Drucker-Prager works well for soils and even to deal with the granular materials. As I told you, the phenomenon of creep when the geologists observe the rock shattering or the material deterioration in the mountains. So hyperelastic is a kind of a compound where you use monirivlin and ogden. It works really well for the elastomers. As I spoke about the gaskets, the seals, the O-rings. You must have heard about the piston rings that seals the lubrication oil from entering into the, that allows the minimum amount of oil to the pistons that keep sliding on the cylinder blocks so that it provides lubrication for the pistons to move up and forward. So as well as this for the cylinder liners for the better heat dissipation because the oil keeps cooling those with the lubrication. The Blatsko is another mathematical model that works well for polyurethane foam rubbers. So viscoelastic material model is combined with various models you can use it. That's for the hard rubber or glass. And the creep phenomenon is definitely, there are special models available, the creep equations with this implicit, explicit method, and depending on the type of test, the constants that you have, you can choose that particular material. This is mostly used in materials where you think that it is experiencing elevated temperatures, and the applications could be high polymer plastics, and concrete and solid propylene. When we talk about super elastic shape memory alloys is very, very interesting because nitinol is one kind of a material. It adjusts its shape based on the super elastic effect because it although undergoes large deformation when you load it and unload it, but it does it without having the permanent deformation. That's the beauty of shape memory alloys. We call it as SMA. Although you elastically deform it and then you unload it, it will not have a permanent deformation at all. It'll still can have behave or adjust itself accordingly. So that's known as superelastic effect. So now we need to decide like, okay, now that we have various categories of nonlinear materials, how do I first of all, where do I start and how do I judge that I can go with this nonlinear material? So first thing that you need to look for is the strain rate important, which means the plastic strain or anything happening which is over a period of time. If you say strain rate is important, yes, then you need to check for whether what kind of material or is there any creep, any temperature effects coming to picture. So you need to include creep. What kind of material is that? If the strain rate is important, because it can be viscoelastic, it can be viscoplastic materials. So based on that, then you decide whether, if the strain rate is not important, you're absolutely fine. And then the next step you can go forward is whether the stress that you get is in linear zone, which means your stress is proportional to strain. If yes, you're definitely going to come back and then model it as elastic, linear elastic. If not, you're going to check where is yielding possible beyond an elastic limit. That's the beauty of steel, as I said, beyond elastic limit, although with the increase of strain, the yielding is possible in a material called steel. So if yielding is possible, yes, that's fine. But once again, when we talk about the red zone, I'm going to show what the red zone is. You must have seen when you plot the analysis results, you have the hot spots, which we call it as red legend, that you see that's nothing but your red zone, your stress concentration. If it's going to be small, then once again, you're going to check, is there any load changes with respect to the time in increments of loads that you give? So if there is any load changes, then you include the plastic modeling plus your hardening into picture where the strengthening begins. If you could recall the stress strain curves, what we had seen just a few minutes before. So this flowchart is definitely going to help one to decide on how to model, whether I'm going to model my material up to elastic or whether it has got a hyperelastic effect based on the materials that you choose. Directly, either if you're going to deal with rubber, you're going to go with hyperelastic. And if you're going to deal with a material which falls in elastic plastic, yes, that you can go with this. And if you're going to deal with a plastic material or beyond the special polymer compounds, which will further stretch and which has got hardening, you can go with the plastic plus hardening. So here's a quick walkthrough of the relevant case studies in the automotive industry. And yes, it's a kind of a push button diaphragm seal. This is not, okay, this is not the automotive. However, it is also used in terms of the automation in the manufacturing lines. And so you must have seen, for the machine to turn on, you should have a push button kind of a diaphragm that has got a seal inside. And no matter what, it just looks like a simple button. When you push it, your seal has to behave. The diaphragm seal, as you could see here, this is a cross section of this such a small diaphragm. You see the plunger over there. It pushes the plunger, the seal gets deformed, and then when the plunger pushes back, because when you remove your hand out of the machine, the button is going to come back to its position, so the seal is going to undeform and deform. So here the seal matters a lot. It's a non-material hyperelastic compound which is included, and as you all know, that the material in nonlinear analysis, we are not going to load it with one static condition. We are going to use the loads in different increments, incremental loads. And these are the plots that you see how the seal behaves when the button is pushed. It comes out and then it sits in back inside. So this is used by a company called Rockwell Automation, and product managers did a fantastic job of modeling this because they are able to evaluate multiple nonlinear material behavior of the rubber diaphragm seals that they use even before they make a prototypes, which is it reduces time considerably, and it also reduces the cost of making the prototype and tooling. That's why simulations play a very vital role. There's another interesting example of the Automotive Engine Control Module. It's a kind of a spacer that has been used. It's once again a material model. They have a challenges where the silicone rubber spaces between a heat source and the heat sink. Your IC chip, whatever that you use in your electronics, it gets heated up. So to cool that, a spacer is kept so that the rubber spacers can take the heat and give it onto the heat sink, so that the IC engine gets cool without any premature failure with overheating. That's the challenge that they had. So they used ANSYS with that compound, and the solution is they used elastomer material. As I had shown you the summary, they had chosen Moni-Rivlin model. They've also used contact elements because they have to represent the surface-to-surface contact between the spacer and the PCB. The benefits are they were able to develop the optimal design, and they were able to improve the life of ECM in harsh environmental conditions. Everybody knows that the global mega trends are, people have this question, is IC engine going to get stopped, or people are going to manufacture electric vehicles? So how is it going to be the transition of IC engine to the electric vehicles? But not yet. The progressive developments are happening with respect to the electric vehicle. However, there are more challenges in electric vehicle with respect to the battery weight, the powertrain system, the speed that it can achieve, and also the overall ergonomics. So, whereas in the other case, the IC engine is still having challenges to develop further because the carbon footprint is a major phenomenon that pollutes the environment. So as you could see, these are the European Union prospected emission targets. That is definitely be the carbon reduction targets. So they're expecting at least in 2025 that it would have further 30% reduction in this. On the right-hand side that you see is nonlinear materials plays vital role in terms of even BIW structures, or for that say any material. So how does the material behave when it impacts any particular, when it hits a pillar, when it hits a crash condition, or even when it deforms under the sunlight or a heat when you park your car on, at elevated temperatures. So the overall, if you could see this particular diagram, whatever the automotive industry is expecting moving forward is they want to develop a safer, low weight, a passenger comfort, all needs to be achieved at the same time. So there are trade-offs they're trying to find out. And while doing this, whether they go for the electric vehicle or the fuel cell or the hydrogen vehicles, and still whether they're going to have the electric vehicle mobility or they're going to have the autonomous vehicle, the driverless car, which can get into the picture maybe after 5 or 10 years in global regions. And those cars should stay connected to communicate in terms of traffic management, emergencies, and the serviceability of those cars in case if it gets failed in the middle of the road trip. So here's the job market survey. These are the market stats in India. You have different social media networks having a lot of openings in FEA and CAE. Especially they look for nonlinear capabilities along with the linear capabilities. And Naukri has got certain 92 openings, and Indeed portal has got 67 openings. This is based on the April month statistics in 2021 that I had plotted. So others category will even have freelancing, where people really look for experts, or even for the people who can do a nonlinear analysis that they could, based on their flexibility for per hour cost. Globally, people had started working with freelancing as well. So on the right side, it is definitely going, the figure is going to be higher because it is a cumulative effect of various countries. However, you could see the significance of this job market in various regions. So who are the major recruiters if you pursue your career in FEA? It is definitely going to be your original equipment manufacturers, tier 1 suppliers, and engineering services organization, whether it's automotive, aerospace, or mechanical industries. So this job openings keeps changing. The stats that I had plotted could be different in this month. So it keeps changing depending on the market potential. So according to Forbes Inc., the recruitment experts indicate that new technologies that I'm talking about, the developments in EV or developments in ICE itself, the Megatrends is going to lead, it is going to give rise to increase in jobs for at least next 5 years. So that's a kind of the global survey says. Now here is a quick look into the goodness of fit. This is nothing but the skill development, which will help to bridge the gap between the industry and the academics. Because for a fresh graduate, there are certain critical skills that is on the left hand side. You see this the blue arrow. So the skills get added depending on the job roles that you may get hired by the companies or whatever that you do in your career. And on the right hand side in the row wise, this will be the change in job roles based on the promotions, or maybe if not promotions, change in your job roles based on your expertise. So analytical thinking is a must for a fresh graduate, even for a 1-year experience who is working as GET in an organization, even if it's 2 years. So there is no change. Analytical thinking is required. Yes, problem solving, the passionate in solving the complex problems, or at least the ideas to solve the problems. So it is going to remain same, but if you're 2 years experience, then definitely you should have the capabilities of even having 100% problem solving capability. CAD is definitely not a very, very detailed concern, but you should know how to read the drawings. You should know how to pick the dimensions required from the drawings, because if you need to give connections in your finite element model, the well size, well length, the bolt joints, and you need the drawings to be, so you should be in a position to read those CAD models and see it, because ultimately once you simulate, if there's any change in the model, your design department is going to change the model according to your analysis outcomes. Pre-processing, definitely yes, if they have good pre-processing, solving, and post-processing. And more importantly, it's not just the color plot that you get out of the screen. So no need to get fascinated because you're having a white collar job, or you may get a white collar job with this. But the most important to sustain to have a very flourishing career in FEA is the interpretation skills. You should be able to interpret the results that you had got, the color plots that you had got, whether it makes sense, whether it behaves as per what you expected or as per the laws of physics, or is it violating the laws of physics. So qualitatively, is it behaving first, and quantitatively validating if that is what is going to experience. Initially with the test results, you're going to validate. Programming language skills is required because you're dealing with the software. So definitely yes. If you have a passion, because you just need to have few expressions to understand within the software that you use. But yes, it is going to play a vital role moving forward. So need not be 100% programmer, but maybe at least tentatively, like roughly 50 to 60%. If you are able to manage with that, that's okay. And final important thing about the skill development is you should be able to communicate your results. You can be good in simulation, you can be good in results, but if you're not able to communicate these skills effectively, then that is going to be a problem. So overall, Apart from that, you have the technical expertise that you're going to develop once you enter into the organization or before entering into the organization to prepare yourself. That's not the end. As I told you, learning is a lifelong process. So and globally in all the countries in the world, the people, they just don't stop learning. We don't stop, right, from school, and we went to the college, and now from the college you're hunting for the jobs. Once you enter into the job, based on the experiences, based on the job roles, what are the skills required for you, are going to scale up yourself. So continuing professional development is a development that is going to expand your knowledge, maintains up-to-date technical skills, because even when you're in the organization, you have to stay updated yourself with the problem solving and also the special skills that is required for you to upgrade yourself either through the organization networks or in a private mode. So you will also grow your professional network once in a while. Once in a year, you attend the software conferences and also the SAE conferences with the like-minded people who had come and contribute themselves to show the automotive community that what kind of work that they had done. So it's a kind of a knowledge exchange platform. So you stay connected with the community every year so that you grow as long as the community grows. That's what keeps you growing. And this leading to a progressive engineering careers. So not making a huge leap. So finally, it is going to lead to a professional status in abroad or even in global locations. Now in India, it is coming up like anything with the certification courses. A lot of institutions offer certifications, registered organizations, and there's always a called a chartered engineer status for the global people. Like if I want to be an expert in reliability engineering, there's always a certification called a chartered reliability engineer, call it a CRE. For example, you need to be good in project planning and management, but your job role demands that it's not necessarily that one has to get certified. So, but yes, it depends on their interest and the time availability. They can go and get certified in project planning and management. So similarly, in simulations, you have few areas where you can upscale your skills with the private institutions which offer industry-leading courses like Skill-Lync. So because what matters the most in terms of continuing professional development is that you need to get trained with the right people and with the right industry experts, because it's only the industry leaders know what are the skills that is required and what are the skills that they look forward when they hire the students or the fresh graduates, and not a commercial institute or not any just a subject matter institute like a CAT center or I'm not trying to pick the names of the institutes, but in general they are doing really a fantastic job. But it all depends in the market, like which organization brings you or introduces the courses that bridges the gap between the industry and the academic. So you choose the right course that fulfills your goals, career goals, and you keep preparing yourself and be prepared if you're a fresh graduate. So this is definitely irrespective of the job market currently in the midst of COVID. So you keep preparing and you be prepared yourself so that when you go it, honestly, me being in the industry, I would always love to hear from the fresh graduates when I hire fresh graduates. So what is a kind of a passion, how passionate they are, and till what extent they know, and how we can hire them and mold them so that they are in a state of mind where they can be trained. It's always better rather than being not prepared and just trying to kickstart there once get hired, or they may not even have chances of getting hired. Thank you very much.